So welcome, we're going to talk tonight. This is lecture 4, and tonight is all about electrical resistance. We've already introduced the concept of resistance through the readings, through previous lectures, through class discussions. But to refresh you, if you don't remember, resistance, when we talk about it in terms of electricity resistance, is a measure of how easily electric current moves through an object or device. So when you hear the term resistance in electricity, and we talk about electrical resistance, it's just how easily electricity can get through something. It's exactly the same as if you were talking about water resistance and pipes. We were talking about that before. We were talking about it. It's the same as if you were looking at how easy it is to get down the football field, right? A football team that has a good defense puts up a lot of resistance, and it's difficult to move down the field. Just like an electrical device that puts up a lot of resistance finds it difficult for electricity to get through that object or device. Some different things that impact resistance, some factors that impact resistance. Well, we saw that how long the resistor is versus or short it is. So the length of the actual resistor can have, or object, wire, can have an impact on how easily it is for electricity to get through it. The area. So if we're talking about a short area versus a, rather not a short area, let's say a small area. A small area versus a large area. And we talked about this in class where what's easier to get water through, a straw or a sewer drain. And because you have a lot more space, it's easy to put a lot of electrons through something. So this area. And one of the other big things that we look at is the materials. So different materials can have an impact in different ways on the electrical resistance. And we'll talk a lot about that when we get to conductors and insulators and what makes something a conductor of electricity and what makes something what's called an insulator of electricity. So when we look at simple circuits, we're talking again about how easy it is for electricity to get through. And a direct relationship. That is, there's a direct relationship between how much the resistance is and how little current can get through. So I take that back. That's not a relationship, is it? That's an inverse relationship. That is, as the resistance goes up, current will go down. So to measure resistance, we have a unit for measuring resistance. It's named after a German physicist. His last name was O.H.M. Ohm. But we don't call it the ohm, we call it ohms. So we measure electrical resistance in ohms. And that's symbolized with the Greek letter, I always have to draw mine very slowly, omega. But if you find the Greek letter omega too difficult to draw and you just want to write out the term ohms, that's fine. So 1 ohm, see, I'm having a hard time drawing it already. And I'm not going to, don't fret about drawing a perfect Greek letter omega. 1 ohm equals 1 volt per ampere. That is, for every volt it takes me to get 1 amp to move, that's 1 ohm of resistance. Because remember, voltage is that energy behind it. This is that cause, this is the energy that causes it, basically. Voltage is a way of our measuring our energy. Another way to think about voltage is it's the push on the electrons. So the harder I have to push, the more resistance I have to get through the wire. So the wires in our home have very low resistance. Very low resistance. And that's the thing, because things that have high resistance are going to take away energy, they're going to heat up. Think of like light bulbs. A light bulb has a high resistance in comparison to the wire. A low resistance like a wire, that's about 0.001 ohms. That's a lot. Well, a light bulb, like the light bulbs we were using in class the other day, have a resistance of about 1 ohm. And some objects can be even higher, things like a toaster. Those little coils get very hot, they take a lot of energy, they take a lot of current, and because of that, they can have very high resistance. So we'll use a multimeter in class to measure resistance of some different objects, and we'll actually do some experimentation with creating our own variable resistors as well. Alright, so all of this leads us to this mathematical relationship called Ohm's law, and this is why we call him the Ohm, because Mr. Ohm is who came up with it. We've already seen it in the reading, and you've done some math practice with a little bit fast, but just to put it on paper here, it's basically this. I equals V divided by R, where I is the amount of current, V is the voltage between 2 points, and R is the resistance of that section of current. Another way to say it, if I want to, I can rearrange, say R equals V divided by I. Or V equals IR. 3 different forms of the exact same equation. And we've seen this triangle in class before too. If you don't remember, here it is. V, I, R. So depending on which of these 3 things I want, do I want current, resistance, or voltage, I can use any one of these 3 forms of the same equation to find that. So we've had some basic practice with this in class. We'll have some more practice with this in class, but it is a very important thing for you to remember for the test, especially as we'll definitely have some math questions involving this. So some different examples of some different household things that you might see around the house. A 100-watt light bulb has a resistance of about 145 ohms. Your skin is about, so skin, yeah, let's write bulb up here so we remember that's a bulb. Your resistance of your skin is about 100,000 ohms. So it takes quite a bit to get electricity to move through your body, at least through your skin. Things like salt water have very low resistance. And then there are, of course, a lot of other objects. We can get into a lot of detail on this, but just to give you a rough idea of some of the things that we're looking at as far as resistance. Alright, we will wrap it up right there. That was a nice little short one. Ohm's law, and what electrical resistance is. We're going to have a couple of labs this week dealing with this and what makes a conductor and an insulator, and talk more about variable resistors, also known as potentiometers. And we're going to cover all that stuff this week. Hope you enjoyed this, and I'll see you next time.